Before we get into some measures of variability, I have an important piece of mathematical advice for you. You ready for it? Don't be mean. Just don't. Instead, be median. See what I did there? Okay. So what you have before you is a list of temperatures in degrees Fahrenheit for Newark, New Jersey, and Cancun, Mexico. Which of these two places would you rather go to? Well, the temperatures might be a helpful way to make that decision. And so this is in table form, all the temperatures through the year, but we've also got it in a dot plot. And this is helpful because we can see right away when we have it in a dot plot visually, there's a big difference between these two places. In Newark, these temperatures are very spread out. They're very far apart. Whereas in Cancun, the temperatures are super close together. You see how in Newark they're spread out and in Cancun they're close together, they're clustered? What we just did is visual inspection. We're noticing how far apart the temperatures in each place is. And that's a useful way of telling how consistent the temperature is going to be. If I go to Newark, it could be 30 degrees, it could be 75 degrees, it could be 50 degrees. There's lots of different possibilities. But if I go to Cancun, it doesn't matter when I go in the year, it's probably going to be somewhere in between 70 and 80 degrees. Pretty consistent. Okay, now we don't just need to do this with visual inspection, we also need to be able to calculate. And the first measure of variability that we need to calculate is the range. The range you probably did over the last several years. The range is the maximum minus the minimum. And so the maximum is the largest temperature, the minimum is the smallest. For Newark, that means we're going to do 75, that's the max, minus 30, that's the min. So 75 minus 30, the range is 45 degrees. Cancun, it's a much smaller range, and we're going to do 80 minus 70. The range is 10 degrees. Now what does this information tell you? 45 degrees versus 10 degrees. It doesn't tell you the temperature. This is not the temperature. This tells us how far we can expect each temperature to vary. This tells us how much variability in temperature is in each city. And I think that's super important because it tells us what to expect. Okay, if it's going to be consistent, if there's a very narrow range of temperatures, that's really important information. Or if it's really spread out, like in Newark, that's also super important. Okay, let's look at a different measure of variability, the IQR. And to do this, we need to remember something about these plots. You should have seen these plots before, but it's okay if you need a refresher. Both of these plots show the same set of data. This is about tires. And each dot on the dot plots is the average tire life in thousands of miles. And similarly, these box and whisker plots also show the average tire life. I want you to remember what a box plot shows us. The dot plots, each dot is a tire. So this is the lowest tire at 41,000 miles. This is the highest set of tires at 50,000 miles. A box and whisker plot also has a minimum and a maximum. So let's label that. The minimum is here. It's the smallest point. And the maximum is here. It's the largest point. The box and whisker plot shows us how spread out they are from minimum to maximum. That's not the only thing a box and whisker plot shows us. The box and whisker plot also shows us the midpoint. This is the midpoint, this line in the very center. And what you should have seen is that the midpoint is the median. So we've got the lowest number, we've got the highest number, and we've got the middle point. And now there's two other points that a box and whisker plot shows us. This is 50% of the numbers. So I'm going to make that clear right here. So here's 50% of the tire data. And then on the other side is the other 50%. A box and whisker plot allows us to take this 50%, it's 15 numbers here, and divide it in half. So this is half of that 50%. Here's the second half of that 50%. This halfway point is called the first quartile, right here on the dot plot. And it's here on the box and whisker plot. It tells us the point that's halfway between the minimum and the median. Similarly, on the other half of the data, there's a halfway point here. And here's the second half. And this is the Q3. It's the third quartile. And what's really important is that a box plot not only shows us how spread out the data is from the lowest point to the highest point, it shows us how spread out it is for every quarter or 25% of the data. So we can see that the middle, or this lower 25%, this 25%, and this 25% are spread out almost equally. They're similarly spread out. But the upper end is really close together. It also allows us to see what's happening with not just the whole data set, but the middle 50% of the data. That's the box. And that's where the IQR, or interquartile range, comes in. Okay, let's take this box plot and let's fill in some information. So the Star Tire Company has a minimum of 41,000. It has a maximum of 50,000. It has a median, and I'm going to my box plot, the median is right here. It has a median of 46,000. And then the first quartile is 44, while the third quartile is 49. Okay, so let's find the range and the IQR for the Star Tire Company. So for Star, the range is going to be the maximum minus the minimum. Range is the max minus the min, so that's going to be 50 minus 41, which is 9,000 miles. Okay, and then the interquartile range is a range. It tells us how far apart things are. But instead of telling us from the maximum to the minimum, it tells us in between the two quartiles. The IQR is the distance between the two quartiles. It's the length of this middle box. And it tells us how spread out the middle part of the data is. So the IQR for Star, the IQR is going to be equal to Q3 minus Q1. So Q3 is 49 minus 44, which is 5,000 miles. So we know that star varies by 9,000 miles over all the tires, and from its greatest to its shortest lived. And in the middle part, most of the tires, 50% of the tires, are only going to vary by 5,000. Okay, go ahead and find the 5-number summary for Dura Tire Company, then find the range and the IQR for the Dura Company. Pause the video and then restart to check with the control. Okay, ready to check? So here's the 5-number summary, and here is the range and IQR for Dura tires. And what you can see in the numbers and in the plots is that Dura tire has a much smaller range and IQR. It's much, much closer together. And what does this mean? This means that Dura tires are much more consistent than Star. It means if you get a tire from Dura tires, you can expect that it's going to be in a closer range of miles than from Star. Star tires could last 41,000 years and they could last 50,000 years. You don't know what to expect. Okay, let's summarize what that means on the next page. So the range and IQR are measures of variability. And you should hear in that word, variability, varies. Because they show how much a data set varies. They show how spread out or consistent a data set is. And think for a second, if data is really spread out, what does that mean? If you have a really high variability, what does that mean? Well, I like to think about grades. If I have a high variability in my grades, like for example, I get grades like 60, 100, 30, 90, 82, 47. I have a high variability because my range is going to be like 70, and my IQR might be 30. It's really high. It means I'm not consistent. I'm not very consistent at getting grades. I don't know what to expect. So a high variability means the data is spread out and inconsistent. Okay, similarly, let's think about if you have a low variability. What if instead of getting grades like this, I got grades like 85, 88, 84, 89, 90, 87, 88, and so on. If I'm getting grades like this, it means I know what to expect. My grades are usually between 85 and 90. My data is really close together. It's really close. It's really consistent. So a low variability like this is going to have a range of like 5. Means that the data is close together and consistent. Okay, so as you're calculating measures of variability and thinking about what they mean, remind yourself, data, that if the variability is high, it's spread out, it's inconsistent. And if the variability is low, it's close together and very consistent. All right, good luck.